Hello everybody, this video covers activity number 4, ratios in the media. A little bit of background information. For a rectangular shape such as a display screen, the longer side is called the width W and the shorter side is called the height H. The aspect ratio is W to H, which can also be written as a fraction W over H. Okay, question number 1. What is the approximate aspect ratio of the screen on your graphing calculator? Consider only the window, not the entire screen. Well, if you measure the screen going the width, that would be 4.7, and the height would be 3.1. So we would say that the ratio is simply 4.7 to 3.1. Question number 2. So number 2 says, find the width and height of an older 25-inch television whose screen has an aspect ratio of 4 to 3. Let's look at the screen over here. A 25-inch television screen means that the diagonal is 25, so that would be from one corner over to the opposite corner. We're trying to find the length of the width, or how long the width is, and the height. Since we know that the aspect ratio is 4 to 3, then we can write that the width is 4 times some number x, and the height is 3 times some number x. We know that this fits a Pythagorean theorem because we have this right triangle. So the Pythagorean theorem says that this length squared plus this length squared is equal to the hypotenuse squared. So we have the equation that 4x squared plus 3x squared equals 25 squared. 4x squared converts to 16x squared, and 3x all squared converts to 9x squared, and 25 squared is 625. We add 16x squared plus 9x squared to get 25x squared, and then we can divide both sides by 25. 625 divided by 25 is 25, and that's equal to x squared. So then we would have to take the square root of both sides. So x is the square root of 25, which is 5. Now we can find these lengths because this side is 4x and x is 5. So that means 4 times 5 would make 20, and 3 times 5 makes 15. So the dimensions of a television screen whose diagonal is 25 is a width of 20 and a height of 15. Now it says find the area of the screen. The area is its width times its height. So we multiply the 20 times the 15 and we get 300. And more specifically, the area would be 300 square inches. Here's question number 3. Repeat this process to find the width and height of a newer 48-inch television whose screen has an aspect ratio of 16 to 9. So here's the representation of the screen. The diagonal is 48. The length of the width is 16 times some number x. And the height is 9 times some number x. That's because the ratio is 16 to 9. Putting this into the Pythagorean theorem, 16x all squared plus 9x all squared equals 48 squared. 16 squared is 256, and 9 squared is 81. And 48 squared is 2304. So we have 256x squared plus 81x squared equals 2304. Adding 256 and 81, we get 337x squared equals 2304. We divide both sides by 337, so x squared is 2304 divided by 337. Then x would be the square root of this fraction. And we put that in our calculator, and we write the answer accurate to 4 decimals, and that would be 2.6147. Now, the width then would be 16 times 2.615. I just rounded that to 2.615 there. 16 times 2.615 gives us 41.8352. That's the width. And the height would be 9 times 2.615, which gives us 23.5323. Then the area is multiplying the width times the height. So that area is 984.4785 square inches. And here's number 4. It says figure 1, which is this figure here. It shows a letterboxed image with an aspect ratio of 16:9 displayed on a screen with an aspect ratio of 4:3. What percent of the screen's area is occupied by the image? And justify your answer. Now, when we look at this picture, we know that the image ratio is 16:9. So let's just say that the width of the image is 16 and its height is 9. Now let's look at the entire screen. The entire screen, remember, has an aspect ratio of 4:3. But if we multiply the 4 and the 3 by 4, we get 16 and 12. So a ratio of 4:3 is the same as a ratio of 16:12. So now we can say that the length of the entire screen is 16 and its height is 12. So when you look at the height of the image, that takes up 9 out of the total height of the screen, which is 12. So the image takes up 9 out of 12 when it comes to the height. And that percentage would be 0.75 or 75%. Therefore, the image takes up 75% of the entire screen. Then there's a follow-up question that says, what would happen to the image if it filled the height of the TV? Well, if the image fills the height of the TV, that means the width would also have to increase by the same proportion. And this would cause part of the image to be cut off from the screen. Now we're going to look at figure 2. It shows a pillared box 4.3 image displayed on a 16:9 screen. What percent of the screen's area is occupied by the image? Justify the answer. So let's go back and look at this image. So the image is 12 by 9. You see, the image is in the ratio of 4:3. But 4:3, if you multiply both of those numbers by 3, 4:3 becomes 12:9. Now, the screen itself is in the ratio of 16:9. So we would say that the entire length of the screen is 16 and its height is 9. So the image is 12:9, the screen is 16:9. What is the percentage of the width of the image to the width of the screen? Well, we can see that this is 12 and this is 16. So the image takes up 12 out of 16, or 0.75 or 75%. And then we have a follow-up question. It says people who own a widescreen television can choose one of 3 views of a 4:3 image on their display. 1, the normal view shows the pillar boxes as shown in figure 2. Number 2, another option is to stretch the width of the image, keeping the height the same. And then the third option is to zoom in on the image, making the width of the image take the full width of the display. What effect do these options have on the screen? Well, if you go with the stretch option, where you stretch the width of the image, keeping the height the same, the stretch option would distort the image, and it seems wider than intended. Okay, if you go with the third option, that is to zoom in on the image, making the width of the image, take the full width of the display. The zoom option would cut off part of the top and the bottom. It would get bigger, but you would not be able to see the entire picture. It would cut off part of the top and the bottom. All right, that concludes activity number 4.